Hi again. Let us now dry run our algorithm for the NQ operation and the DQ operation. You can see that I have just depicted that array and we have initialized the rear and front there at 0. So the rear is at the 0th index and the front is also at 0th index at the very beginning when we start. Now I will be performing these NQ and DQ operations, all of these one after another, and we'll see how these algorithm actually works to get us first in first out data elements. Okay, let's start with the first operation. Now we are calling the NQ. This is the first operation. Okay, so we are passing on 5 there to the NQ operation. So this V is going to be 5 for the very first time. Now we are checking whether the Q is overflow or not. Is the rear at the size? No, it's not size. Rear is 0 right now and the size is 5 for this array. Okay, let me write it here. Size is 5. That's the size of the array. So the value of rear is 0. So that is not true. So we are coming here and what we are doing, we are placing the value V, that is 5, at the rear index of the item array. So it will be placed here. And then what we are doing, we are moving the rear to the next element. So let me just draw that. So we are moving the rear to the next element. We are increasing the value of rear by 1. So rear is now 1. Now again, we are calling the NQ operation once more. And this time we are passing on 10. So the value of V for this NQ is going to be 10. Now let's see how this NQ actually inserts this. Again, the value of rear is now 1. It's not size. So we are coming here at line number 24 and the value V, that is 10 right now, will be placed at the rear index, that is 1 of this item array. So 10 is inserted here. We have placed 10 at the rear index. Now the rear has to be moved on. We need to increase the rear to the next element. So rear is added with 1. So rear goes here. 1 plus 1, 2. And now let us go ahead and we call the NQ operation with 25 for the next time. And this time it's 25 at V instead of 10. Okay. So now let us see how this 25 gets inserted there at the rear index. If the rear is size, no, it is not, because the value of rear is 2 and the size is 5. So that is false. Again, we are coming here at this line number 24. And the value 25 is placed at the rear index, that is the index 2 of this item array. So 25 will be placed here and then the rear is going to be moved up again by 1. So we move the rear here at 3. Now we go ahead and we call the DQ operation. Now let's see how the DQ deletes the front. So we're calling the DQ operation. This is our DQ operation. You see, first of all, in this, what we are doing, we are checking whether the queue is empty or not. If the rear and front are having the same value, then only the underflow happens. So the value of rear is right now 3 and the value of front is 0. So they are not same. We are coming here and we are going to pick up the value which is there at the front index. So you can see that item front value of front is 0 right now. So the V is going to be 5. So we are picking up V equals 5. And what we are doing, we are just moving the front to the next element. So front goes up there to the index number 1. Now we are not practically deleting this 5, you see. We are just moving up the front to the next element. That doesn't matter actually. Always we will be picking up the value from the front. Front is the index from where you are actually delete the element from the queue. So if the element is practically not deleted from the array, that doesn't matter, because we are not going to be able to access this element because the front is up now. So theoretically it is deleted from the queue. This 5 is returned by this DQ operation now. So that's the first value that we inserted into the queue. So we get the 5 as the first value when we delete. So that's working actually. First in, first out is followed. Okay, let's see. Move ahead and we are calling the DQ operation once more. Then we are coming here, rear and front are checked whether they are equal or not. No, they are not equal. Still the rear is at 3 and the front is at index 1. So they are not matching. We are again coming at line number 34 and picking up the value from the front. This time it's going to be 10. You can see that the value of front is 1 and item 1 is 10. So this 10 will be picked up and will be assigned here at V. So the value of v this time is 10, and then again we are moving the front to the next element. We are moving the front up. So front goes here at the index 25. Front will be moved up. Now, if you call the DQ operation once more, then obviously you are going to get 25 from the DQ. And so let me just call the DQ operation once more. I'm calling the DQ operation once more, and now let's see what is going to happen. Rear and front, they are not still same because the rear is 3 and the front is 2. So it's going to pick up the value from the front, that's 2, index 2. So v is 25 this time. So v is 25 this time. Let me just clean the screen. Now we move up the front by 1. Front will be increased to the next element. So the value of front was 2. Now it's going to be 3 this time. So it's going to be here. Now you see that the value of front is 3 as well as the value of rear is 3. Now v is going to return. Now the value that is going to be returned from DQ is 25. Okay. Now if you call the DQ operation once more, then the underflow will happen. Now let's call it and see how the underflow condition is actually satisfied. We are calling the DQ once more. Now this time the rear is having 3 and the front is also at 3. So this equality operation is true right now. So the Q is in underflow condition and it will exit the DQ operation. So that's how the underflow actually takes care of. So as far as this dry run goes, we see that we are getting the first in first out order with this algorithm. So in the next tutorial, I'll be implementing this NQ and DQ operation using C programming language. Join me in the next tutorial and see how we can implement this. Thank you very much.